Okay, so for today, we'll be solving questions in the motion in one dimension. Those are the questions that we'll be solving. So, what we have here is this question which is here. That's what we have. It says the position of the particle is given by xt equal to 3.0 t to the power 2 plus 0.5 t to the power 4. The first question says calculate the average velocity between 1.0 and 3.0 seconds. So what do you do? So the first thing that you do here is to write the formula. So the formula, it will help us to know what is necessary. So for example there, that's the average velocity. So in the average velocity, it is the final displacement minus initial displacement over final time minus initial time. Now here in the question, we have been given the displacement equation. So since we have been given the displacement equation, what do we really need to do? And remember that we've been given the time. So we have been given the time initial and the time what? Final. What's the time initial? It's 1.0. So this is the time initial. So I'll substitute in the equation this time initial, which is 1. I've put 1 there. So 1 to any power, the answer is what? 1. So in that situation, it's just 1. So you have 3 plus 0.5. What would be the answer? 3.5. That is meters. Okay, now after doing that, we need also to find the displacement after 3 seconds, which is the time final. So we still get 3 and we substitute wherever there's t in the given equation. So this is 3, then that is what? 9. 0.5. Then 3 to the power 4, that is 81. Then 3.0 times that is 27 plus 40.5. When you add there, it will give you 67.5, meaning that 67.5 meters. That is the final displacement, and our initial displacement is 3.5. What's the question? The average velocity. So you get the average velocity formula. You write it here. Then what is the final displacement? 67.5 minus initial displacement 3.5 over time final 3 minus then initial time 1. So you have 64.64, right? 0.0 over 2, meaning that when you divide there, it will be 32.0, or the answer is 32, just like that, meters per what? Per second. So this is what we call the average velocity. Okay, now let's go to the other one. So on the other one, we have been asked, what exactly have been asked? They're saying calculate the what? Average acceleration. So in a situation whereby I've been asked to calculate the average acceleration, what exactly we have been given? We have been given the displacement equation. That was what we've been given, right? So since we've been given the displacement equation, what do? We have to differentiate this to be what? A velocity. Now let's differentiate this to be a velocity. So it will be dx over dt equal to 2 times 3. What's your answer? It will be what? 6.0, then t to the power 2 minus 1 plus 4 times 0.5, the answer is 2, then it will be 4 minus 1. So you have this equation that we have differentiated. It is what we call this velocity equation. That is 1 plus 2 to the power 3. So this is the equation that you have been given. Now, what time exactly? Time initial, it is 1.0. So let me substitute 1 there. So it will be 6, 1 there, plus 2, then 1 there. So you have 6 here plus 1 to the power 3, that is 2. So there, what's the answer? It will be 8 meters per second. That is the time initial. How about time final? Time final, it is 3.0. Now, I'll get the same equation, the velocity equation there. I'll put 3. So 6 times that is 18. Then 2 there, 3 to the power 3, that is 27. So you have 18 plus 54. So 18 plus 54, what's the answer? 72 meters per second. So that is the velocity final. Now the question says the average acceleration. Since it's average acceleration it will be v final minus v initial over t final minus t initial. What is the average final? It is 72. How about the initial? 8 over time final 3 minus 1. So when I subtract there, it would be what? 64 over 2, meaning the answer to be 32 meters per second. Just like that, right? So squared, meters per second squared. So that's how we answer the average acceleration. Okay, now let's also look at the instantaneous what? The instantaneous acceleration, right? Instantaneous velocity, sorry. So in that situation where we've been asked calculate the instantaneous velocity. So instantaneous velocity in this situation, what do we do if you have instantaneous velocity? So here what we do, we differentiate. In short, what do we differentiate? We differentiate the equation of the displacement, the one that you've been given. So let's differentiate this one. So it will be dx over dt. Then 2 times that, it will be 6.0. Then t, 2 minus 1. 4 times that, it will be what? 2. Then 4 minus 1. So after differentiating this equation or the displacement equation, I'll have the velocity equation, which is 6.0, 1 there, right? Plus 2, that is 3. So you have 6t plus 2 to the power 3. So this is the instantaneous equation, right? Now since that is the instantaneous equation of the velocity, but the question is asking us to calculate what exactly? The instantaneous velocity at what time? At 2. So I'll substitute 2 wherever there is t. So that is what? 12. And that is what? 8. So you have 12 plus, when you multiply there, 16. So you have 28 meters per second. So that is what we call instantaneous velocity. So if you have instantaneous velocity, which is that, then what's the next thing? Calculating now the instantaneous what? Acceleration. So how do we do that one? We have to differentiate the equation of the velocity. So what's the equation of the velocity? 6t plus 2t, that right? So let's differentiate that one. dv over dt. It will give us what? Acceleration. 1 times 6, it is 6. Then 1 minus 1 plus 3 times that, it is 6. Then 3 minus 1. So you have 6t to the power 0 plus 6t. Then 3 minus 1, 2. So our acceleration, 6t to the power 0 plus 6t to the power 2. You have t to the power 0, what's the answer? It's 1 times that is 6. Okay, now at what time exactly? At 2, so you put 2 there. That is 4. That is what? 24. 30. So the answer is 30 on the last one. So this is instantaneous. This is here instantaneous velocity. Then this is what? Instantaneous acceleration. So that's how we answer that question. Simple and straightforward.